All right, our last objective for this unit is that you will take the derivative of an integral using the fundamental theorem and chain rule. In class, we will go through the math of why this works, but here's the basic idea. Derivative and integral are inverse operations, so they cancel each other out. When you have them at the same time, essentially you're going to end up with what you started with. However, if your limit is something other than a regular x, then there's this chain rule thing to consider. However, in our first example, it's just x. Derivative and integral cancel out, and this expression just becomes cosine of x. That's it. Basically, what we're going to do in other situations is we're going to take whatever the function is, in this case 2x, and plug it into the function inside the integral, and then also because of chain rule, multiply by whatever its derivative is. So this will be very straightforward as well. In this case, it's going to be cosine of 2x times whatever that derivative of 2x is, so that's 2. And that's it. You could write the 2 out front, of course. But our final example here is what to do if you have two functions. And this is going to look like that part of the fundamental theorem where you plug in the upper limit and plug in the lower limit and subtract. This chain rule part still applies. So I'm going to start by plugging in x squared. So this is going to be 4 times x squared cubed. So I plugged x squared into the t cubed. The derivative of x squared is 2x, so I'll multiply this by 2x. And then I'll subtract the same thing, the same idea, plugging in 8x. So that would be 4 times 8x cubed times the derivative of 8x, which is 8. And before I simplify this, I just want you to know that technically this subtraction thing applied to these two as well. And I don't recommend you go back and write this, but look, if we had subtracted cosine of 17 times the derivative of 17, well, derivative of 17 is 0, so all that just disappeared. Here, we would have subtracted cosine of 0 times the derivative of 0, which is 0, so that all just disappeared. So if you have a constant, you don't need to worry about this. It's only when you have a function, like we did in this third example. I'm going to simplify this, but really we're practically there. This is going to be 4x cubed times 2x, so that's going to become 8. I'm sorry, I think I said 4x cubed. This is x squared cubed, so that's x to the 6th times another x, so that's x to the 7th, minus, in this case we have 4 times 8 cubed times another 8, so I have to grab my calculator for that. That comes out to 16,384. Again, that was 4, 8 cubed, and 8. And then x cubed is just x cubed. These are not like terms, so we are done.